This is a video on integrals that involve the arcsine of x. The question is to integrate dx divided by the square root of 4 minus 9x squared. And we're going to use the formula that says that the integral of dx over the square root of 1 minus x squared is equal to the arcsine of x plus a constant. Our integral is not quite 1 minus x squared inside the root, but we can make some adjustments and make it close enough. The first step is to deal with this 4. If I pull the 4 out of a square root, it becomes a 1/2, and it's in the denominator. It'll still be in the denominator. But I also have to pull a 4 out of the 9. It doesn't have a 4, so I multiply and divide by 4. And what I get is 1/2 that was pulled out times the integral of dx over the square root of 1 minus, and then we divide it by 4, so 9/4 x squared. At this point, notice we can rewrite 9/4 x squared as a perfect square. Write that as 3x over 2 squared. Now I'm ready for u substitution. I want this to just be one variable squared, so I let u equal 3x over 2. And then du is 3/2 dx. And then multiplying by 2/3, I get 2/3 du is equal to dx. Now I can substitute. So what we get is the 2/3 got pulled out. We have a du over the square root of 1 minus the 3x over 2 became u squared. And that's great because that is the form of the arcsine. The letter's just different. So I can rewrite that integral as, first thing, the 1/2 times 2/3 is 1/3. And the integral became arcsine of u plus a constant. And then the final step is just to resubstitute. U is 3x over 2. So my final answer is that the integral is 1/3 the arcsine of 3x over 2 plus a constant. And I'm done with the problem.